Alright, this is chapter 1.6, modeling with linear functions. This is the core concepts. There are two core concepts in this. One is how do you write the equation of a line? Well, how you write the equation depends on what information you're given. Okay? If you were given a slope and a y-intercept, man, your job is done. Just plug into, we'll say plug in y equals mx plus b. Okay? Remember, m equals the slope. Alright? Which again, slope is the change in y divided by the change in x, or another way of thinking of that is, hey, subtract your y's over subtract your x's. Those are all equivalent statements. Alright? And b is your y-intercept. Alright? B is your y-intercept. Cool? So, if they give you a slope and a y-intercept, just plug it in, you're done. Alright? If they give you a slope and a point, basically we're going to they say to use point-slope form, which is not bad. If you remember, point-slope form is that y minus y1 equals m x minus x1. If you remember that formula. We're not going to use that. What I want you to do is I want you to plug m and xy, and whatever that point is, into y equals mx plus b, and solve for b. That would be step one. Pardon me. Step two would be to plug m and b into y equals mx plus b. Okay? So we're still using the exact same formula. We're just going to plug in the m, and whatever x1 and y1 is, literally plug them in right here. x1 is x, plug it in for x, y1 is y. Let me see what's going on with my dogs real quick. Give me a second. Alright, last but not least, I just figured out that somebody next door is being stupid, so my dogs are barking at them. Last but not least, if you're given 2 points, well, so what? Use your find m. Sorry. Remember, m equals whatever the change in y is, whatever the change in x is, so just subtract your y's and divide it by subtract your x's. So y2 minus y1, just subtract the y's and divide it by, subtract the x's and reduce. So that gets you m. And now that you've got m, so that would be step one. Step two would be to follow step 1 and 2 above. And I mean those two. Cool? Basically, here's the deal. If you got 2 points, you can find a slope. Subtract the y's, subtract the x's, and reduce the fraction. If it's a whole number, great. If it's a fraction, great. Alright, once you get those, plug your m, and one of the points, it does not matter which one you use, so long as you're consistent. I mean, if you use this y, you have to use this x. If you use this y, you have to use that x. So, I mean, you've got to stay consistent. But pick one, plug them in, solve for b, and then plug it in for that. You got your equation. Okay? Let's move on to the second core concept. Alright, finding a line of best fit. Finding a line of best fit. Now, there are ways of doing this on your calculator, but if it says to estimate, or if it says approximate a line of best fit, this is what they're asking you to do. So step one, make a scatter plot. Basically, graph the data. Okay? Step 2, I'll change colors. Sketch a line that best fits the data. Okay? And just kind of as a note, there should be about the same number of points above and below. So basically, here's what we got so far. So step 1, put your dots up there. So dot, 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 dot. Now, obviously, I'm making this up. Okay? Step 2, graph your line. Well, this one actually looks like it goes about like that. It's not great, but you need to use a straight edge, whether it be the side of your ID, the side of something. I just can't with this program. All right? See if I can do a better job than that. Actually, I want to do better dots than that. I want to choose different dots so I can... How about this? I like that. So this line goes about like that. And now they're not asking it to be perfect on top and bottom, but you notice how you have about the same amount on top as you about the same amount on bottom. So it's a good approximation. It's not perfect. Step 3. Choose. Let me erase that and try again. Choose 2 points on the line and write an equation for it. Now, actually, we'll do that in a second. Pick 2 points on the line. Now, note, they do not need to be data points. Okay, they don't need to be data points. Now here's what I mean. You find this line, and you notice how all your grids have crosshairs like this? And you can see your points. Well, basically, pick 2 points that are as close that you can approximate what they are. Like, you could pick this point right here, and you could pick this point right here. You know, pick 2 points that you're like, hey, that goes to this, that goes to this. You can figure out what they are. They do not actually have to be data points on your line. Okay, they don't have to be. It's okay. All right, and then finally, write an equation using those points. Now, this is one of those times when everybody's equation is going to be a little bit different, because your lines are all going to be a little bit different, your graphs are going to be a little different, your points are all going to be a little bit different. But in the end, they will be very similar. Okay? So those are your concepts. Let's put them into action now.